Hey everyone, today we are going to solve another problem from the DSA, which is from the graph series. So the problem is topological sort, and the problem state like that: if a given adjacent list for a directed acyclic graph where adjacent list of I contains list of all vertices j, such that there is a directed as from the vertex I to j with v vertices and e edges. So our task is to find the any valid topological sort of the graph is exist or not. If there exists, then return 1, else return 0, I think. Yeah. So so what is topological sort? If there exists as between the u and v, then u must be before v. So what I mean by that, let's say we have given this graph and we have adjacency list like 1 is adjacent as is 0 and 2 adjacent as is also 0 and 3 adjacent as is also 0, and for 0 there is a null. So if we say there exists as between 1 and 0, so we have to conclude that for topological sort 1 will come before 0, means in this order, and for all these like there exists 2 to 0, then 2 will come before 0 like that, and if there exists 3 to 0, then 3 will come before 0. So this is our answer. This may be very like 1 2 3 then 0, 2 1 3 then 0, because we don't have the relation between the 1 2 3. So we have to find this order. If this exists, then return 1, else 0. Okay. So how we can find this order? Let's see. So for finding the order, we can apply the BFS here, in which we consider a in degree array. We consider a in degree array like 0 1 2 and then 3. We count all in degrees of these nodes, like here the in degree is 0, in degree 0 0, and here is 3. So add into this array like that. If there no any node which have in degree is equal to 0, then we will push directly into the queue. So here will be 2 3, because all these 3 have in degree is equal to 0. So one by one we will pop from the queue and find the adjacent of 3 adjacent is 0. Then we will decrease that adjacent node in degree by 1. So by decreasing that, so basically what we are doing that if we remove the 3 as between 0 and 1, so the in degree of 0 will be decreased by 2, 3 to 2. Then next will be and we have to take the answer, like if we pop this, that will be pushed into the array which we have to return, like the order of the array. Then next will be 2 adjacent is 0, so we will remove this and decrease the in degree. So decrease the in degree. This is not equal to 0, so we will not push into the queue. if this will be 0, then we will push into the queue. Then the next will be here we 2 and then pop from the queue, and we get 1 whose adjacent is 0 also. So we will remove this edge and decrease the degree by 0. Now this degree in degree of 0 node 0 have in degree 0. So we will push into the queue, node we will push into the queue, then pop we don't have any adjacent, so basically we get the answer. This is our topological sort that we have to return. So we can take another example also. You can dry run on this same concept. We have to consider the queue in degree array. How we will find the in degree array? So for in degree array we have given the adjacency list, like in the question we have given the adjacency list, and so for finding the in degree we will go like from every node we go to the V and to the adjacent, how many adjacents it will have, and adjacent of V, and if we will like that IT plus plus, that will count the in degrees and push into that vector of array. So let's code this up and let's see what we have. First we have to find the in degree of every node. So in the starting we have 0 in degrees, and then we will one by one traverse every node and plus plus. For every node we have to find the adjacent of that node, and we will increment the in degree of every node plus plus, just like we do in the ordered map or unordered map. Then we have to consider the queue data structure, and for that if any of we will traverse into the in degree, if any of in degree is equal to 0, then we directly push into the queue like that. Then we consider we have to return the answer also, so we consider the int topo answer, we can say, and one by one we will pop from the queue until it will get empty. So the node is queue dot front, then we will pop from the queue and we will push that node into the queue, into the answer, so that we get our topological order. IT of adjacent, now we are finding the adjacent nodes of the node. If there are adjacent node, and we will remove that from the in degree, so IT minus minus, and then if this in degree of IT is equal to 0, then we will push into the queue like IT. So in the last we can return answer. Let's see, we have answer is correct. Now try to submit it. Yeah, we got the answer correct.